Hi, welcome back to our channel and back to the tutorial for deep learning. This session we are going to discuss the basics of VGG16. So here now the basics of VG16, what is that and why we need and what are the role of VG16 in deep learning and n number of applications became the VG16 here. Previously I given some video, but here I'm going to give the crystal clear more points. If you're a beginner, it will be very useful for you. The VG16 is it plays for not only object detection, it may extend and work for image classification too here, where we can work with Google Colab, PyTorch, and etc. So these are general architecture of VG16. Let's go for deeply. So first of all, clear idea about what is exactly VG16. So it's one of the familiar convolutional neural network where designed for image classified task. Moreover, it become very popular because of it's always simple and follow the uniformed architecture and performance also very strong and recognize the problems very in visually very easily here. So if you consider the VG16, the name is like 16 means 16 layers. VGG19 means 19 layers. So here it generally consists of 16 layers where 13 convolutional plus three fully connected layers. These are layers developed. These are model developed based on the compute CNN only. Then it always utilizes the repeated 3 by 3 convolution filter for future extraction. Then it may reduce the spatial dimensions where it consists of max pooling operation also. Then it gives the final results, that is predictions based on fully connected layers with the softmax only. Here the term says that the model generally achieves 92.7 test accuracy on image data. That means how means here classification given because generally it's one of the familiar object detection as well as the classification algorithm where it can classify 1,000 images of 1,000 different categories with 92.7 accuracy. So remember, so if you have 1,000 images, whatever the different category, we can categorize that we can done with the help of this VGG16 model here. And again, it's one of the very popular algorithm also, where we can utilize the VGG16 with the transfer learning. So here, once come to the architecture type, just in the diagram. Yeah, here you seen. Yeah, sir, just now told you convolution plus real user, max pooling is there, fully connected plus real user, and softmax there. So these are developed based on the CNN, that is convolutional neural network only. So some of the operation common same here. So here, so this general design for image classification and 16 layer is there. Out of 16, 13 represent is convolution and 3 represent the fully connected layer. Where convolution layers are always followed by the max pooling for downsampling purpose here. So these are the one future extraction. Since all of you know about the future extraction, because even you have already go through the CNN, because generally the CNNs are designed to automatically and adaptively learn spatial hierarchies of future from the input data. Here this helpful for learn effectively pattern recognition, yeah, another visual task also. Then layer architecture. So CNN also follow the this concept where fully connected layers. These all are helpful to extract the process features from the input data only. It may be image in the sense it may image or audio or sorry image or video also. Then wide application. So when come to the terms of CNN, where we can use for image recommended video recognition system and NLP and many other machine learning tasks also. So once come to the key features of VG16, first one say depth and configuration, next one by the uniform filter size, another one called the image net performance. So here, since told you if you want to develop some small applications and you want to go for object detection and image classification, you can follow the VG16 here. It is possible. And uniform filter size because it always follows and utilizes 3 by 3 convolution filters where constant framework is followed here and computationally efficient also very nice. And then once come to the ImageNet data set large scale competition, the VGG16 achieved lot. And architecture, once come to the architecture and structure, we can say convolution layer is there, followed by fully connected layer is there, another called the activation function. The purpose of convolution layer is simple because it generally consists of two convolution layer where another three is that these also helpful to understand of the input data and start work with the input data. Next, fully connected layer. The role of fully connected are very important because this gives the final prediction decision based on the extracted features. For example, if you have 1,000 objects, suppose you have a cat, you can again train and get the output of cat only. Or else if you have a dog like that, you can again train and get the same day output. Then orchestration functions. These are relay functions because these help the network to optimize nonlinear mappings also. And then if you want to know this layers information simple, where conserve input processing, complex feature extraction is there, and effective feature hierarchy is there, and role of pooling layers very important because the pooling layers helpful to reduce the feature reduction, and translation invariance also resolved, and generalizability also completely resolved by this pooling step only. Then fully connected. So the final output trained and got through this future layers only, fully connected layer only. So here these are aggregate. Here fully connected are combined, are relevant and also helpful to relevant features extract from the earlier layers of the network here. So let's see here. This input data is there. Then CNN activation layer followed here. Followed by max pooling is there. Flatten layer is there. At last fully connect layer. So whatever the object classification, sorry, image classification, object direction, anything, you can go set with the VG16 here. So at last it will give the result here. So the decision is very simple, and your final stage where the network makes decision about the class and also say which category of the image from the input to decide and give here. So at last conclusion. So successfully you can use VGG for small level of V16 for small level, and later if you go for time you can go and work with the examples also, and medical imaging also you can work and get the help of this VGG16 for detection diagnosis of small level medical conditions, and domains. Some domains you can work with image classification, and autonomous vehicles also we can get the help of this VGG16 because some small level autonomous vehicles and self-driving techniques, you can follow this VG16. I hope that today you understand what is VG16 and why we need VG16, what is the architecture of the VG16, and where and how can it work, and what are the layers and functions of the VG16 and etc. Thank you for watching the video. If you like the video, please subscribe, share with your friends. Thank you.